Hello all, welcome back to CAD Technologies. In this video, we'll be seeing a step-by-step tutorial of how to make a wrench. Firstly, let us understand the drawing. There are two views provided to us. This is the front view, this is the bottom view, and you can see all the dimensions provided to make this wrench. Now, we can use a surfacing module to make this to achieve the perfect shape. Let's begin by making this model using a surfacing in CATIA as a CAD tool. Under mechanical design, there is wireframe and surface design. So using wireframe and surface design, first we'll make the model and then we'll convert it into a solid. Now, first I'd like to make the shape in the surface form and then add these and then add the holder. Now, let us begin by making the semicircle shape and taking the top view. Okay. Now understanding this dimension is 32. The overall length from the center to the end is 25. You can give it this way or you can make the internal shape and also give the dimensions. Now, this is supposed to be. Continuing with the shape, it goes this way, and then the straight line, and then the arc, and the straight line, and then the closure. Now, we know this particular dimension is 15 as shown in the drawing. As you can see, it's given over here. The distance between these two is 34, which is again given in the drawing. This is already taken as your default. Now, this is not completely constrained, so let me try to make this vertical and then constrain it in line with this. This is the shape, as you can see. Once I exit, I would like to extrude this as a surface. Now, while creating an extrusion, that is an addition of material, I'd like to do it both the sides because to create this non-uniform surface, I need to have the path exactly at the center or the center curve exactly at the center. So what I'll do is I'll give a symmetrical extrusion on both the sides or I can use mirrored event. Either one is the same. Now as you can see, the material has been added. The sketch actually has one 25 dimension missing, so let me try to give that. Now, to create a closed shape for this, we can use your fill command. While creating a fill, you can select all the edges or you can create the boundary. It's up to you. I'll select all the edges. Boundary, I'll give you a separate tutorial on the boundary command. This is the first closure. Similarly, on the bottom side, we require to fill. So let me try to fill on the bottom side as well. Now, since they are disjoint surfaces, we have to join them together. We can use a join command to join all the three to get together in one attempt using the join command. Now, secondly, let's try to make this shape. You can either take 10 or you can give the overall length which is 15, whichever is flexible for you, you can do that. This is 15 TYP. So first we need to get the 13 and since it's a non-uniform addition of material, we need to use a multi-section sweep. Multi-section sweep or multi-section surface is basically required when you have non-uniform profiles. But before proceeding with this, we need to have the path or the center curve or the profiles pre-designed or pre-sketched or pre-defined before using the command. So let us try to do that. I am taking the exact center location. So I can create a point exactly at the center location and take a plane at that location as well. On this plane, let us try to make the path first or the center curve first. Path or center curve is the same thing. Now we know the overall length is actually 30, so let's try to give that as 30. Exit. Now we have two profiles, so I'd like to sketch both the profiles. On this is the bottom profile, as you can see. On that there is a top profile. So considering this as my center, the overall dimension in the end should look like this. So the dimensions are 10 TYP and 15 as the length. So I am taking this 15 as the length and the overall this thing to be 10. This is supposed to be 10. Now I'll just coincide all the edges. You can use references as well, no problem. Exit. Now we have a second path on the top. We have a second path on the top. Actually, this is not completely. It's a 10 TYP, so it's supposed to be 10 by 10 symmetrical line. Perfect. Now on the top we have the other shape, which is 15 by 15. Again, I'm trying to take a plane. On this, I'm trying to make the sketch. This is the 15 I'm talking about. Again, I'll be using this center for my reference and then making a center line, so I can use that reference. Now start making my profile. Let me try to take these as the references so I don't have to coincide it later again, and then try to make the sketch. Now since we know the dimensions, this is already 15, so I'll try to give this as 15. Now to add material in between these two, we'll be using a multi-section surface. Again, I have a multi-section surface. Let's try to select both the profiles. Let me go back to your isometric view. Let's try to select the profiles and the second one. Now, to get a very precise addition of material, this is the way we usually get it. But you want to get it a little more in a little more precise manner. You can use couplings if you want. I can use couplings. I can use coupling for two profiles. So I'm trying to use coupling here to achieve a little more smoother surface rather than what I have got as the result. I want it exact. This will be the exact. Now you can mirror this. Please do a mirror before doing a join command, because mirror will not work after that. You can use symmetry onto the other side. Now you can use either trim or the join command. Now we have to trim off the unnecessary or split off the unnecessary surface, which is this part. So we can select both of them, and as you can see in the light yellow color, this part will get split or trimmed. Once I say OK, you can see the overall structure. The same way I can use it to this shape as well and say OK. This will be the overall shape. These need not be joined. You can join them. Need not be joined, but you can join them later in the sessions as well. No problem. Now, continuing. The path it is supposed to follow is continuing in this manner. So in the front plane, I'd like to make the sketch. I have a front plane. On this, I'd like to make the sketch, which actually begins from here, which is 22. They both the surfaces both are they both coincide, and once we trim the unnecessary whatever the joint portion gets trimmed off. So let me try to use a silhouette projection first and then start continuing. Let me get it back to the actual shape. Now on the front view, I'm taking the front view. Now continuing. The profile I need actually starts from here. I'm taking it this way. Now let me give dimensions one after the other so we can maintain the curve exactly the way it is supposed to be. From here to here is given as 80, so let's try to maintain the 80. There's also another line over here which is supposed to be 20. It is also supposed to be at a height of 20 from the center, so I'm taking that as well. Now we'll try to make these two arcs. It's a little easier to do it this way. We can maintain both the dimensions. And the first one is actually 114 as given in the drawing. And the second one is 40. So before that, let us try to give the overall dimension from the end. So we don't overlap the circles. Now let us try to give the 40. As to maintain tangency here as well, it does not require another dimension. It will auto take the dimension, so no problem. Exit. This is my path. Now there are two non-uniform profiles, one at this corner and one at that corner. So let's try to make them. Let's start with this corner and use this sketch to further proceed with the rectangle. Now this is my reference. I'll be using that as my reference. And now here I'll be making the rectangle. I'll be using a center rectangle because we have taken the mid surface, and the dimensions towards the end are 34 and the overall is 8, which is constantly maintained. So this is supposed to be 34 and this is supposed to be 8. Similarly, there is another profile at this end, as you can see. So let me try to take a plane at this end as well. And on this, let's try to make the sketch. Here, since it's the center, I'm not taking any references because I already have h and v. And instead of giving 8, you can actually coincide this over here because the overall addition of material for that body is 8. But the overall length is actually 22, which is provided over here. Exit again, this will be your sketches. Now let us use multi-section surface as we have used earlier. We can use coupling or we need not depending on the requirement. So once I say preview, you can see the requirement. Now to avoid these, I'd like to use coupling. I want a little more smoother profile. So let me try to use coupling. If you're okay with the result, you don't have to use coupling at all. I want to show you with the best achieved shape. As you can see, this is the best achieved shape. Now you can trim off whatever is not necessary in between these two profiles, whatever you need not, you can trim off. Once you say okay, it will completely become into one joint surface. Now you can fill this area because we need to completely solidify the profile and then join them together. This is your surface. You can convert it into solid or you can give rounds here as well. So, but let us try to convert this into solid first. Going back into your part design, we have to convert this into a complete solid because this is a complete solid. There are no thicknesses or anything provided for us. And let me hide the previous surface and you can see the solid body. This is the solid body. Let me try to hide the sketches as well. I think there are a little too many. It's creating some level of confusion. Let me try to hide those so you can see this ones. Now last are the rounds. You can give rounds in surfacing as well, no problem, but I'd like to give it here. So let me try to select the edges first and give rounds. And now I have these two corners which I need to give rounds to. That's actually 25. Now, the complete end is actually a complete round. So you can use a tritangent fillet to create the complete round. This is your wrench. It's a fixed wrench. This is how you make it using surfacing as well as a solid module. If you want to learn more about advanced surfacing or if you want to learn more about generative sheet metal wireframe design or generative sheet metal design, if you want to also learn more about freestyling, you can generative shape design, you can contact us. Our details are given in the description below. You can learn a little more advanced level of surfacing and then you can make a little more complicated shapes. You can also make shapes which are in front of you on regular uses like your bottles, etc. So if you want to learn more, you can contact us. Meanwhile, keep liking and subscribe to our channel for more tutorials like this. Thank you.